Hello, grade 3. How are you? Hope you're fine. Today, inshallah, we will start chapter 2, part 2, lessons from 15 to 20. Our content in this part: arrays and multiplication. Arrays and multiplication. Arrays. What are arrays? We studied arrays in grade 2 and we said any array is set of columns and rows without any gaps. Okay, repeat with me. Set of columns and rows without any gaps. Set of columns and rows without any gaps, like this. We have here an array of hearts. It contains some columns and some rows without any gaps. We don't have any missing item here. Okay? And we said columns are the items which arranged in vertical way or vertical direction. Okay? And rows are items which are arranged in horizontal way or horizontal direction. Okay, in this array, the number of rows, how many rows here? We said rows are items in horizontal direction, horizontal lines. Okay, so let's count together. 1, 2, 3. So we have 3 rows. The number of columns are items arranged in vertical way or vertical direction. 1, 2, 3, 4. So we have 4 columns. Okay, let's give this array a name. We said before the name of this array 3 by 4. 3 by 4. Columns by rows, okay, or rows by columns. In this year we can write columns by rows or rows by columns. Both of them are correct. Let's write the repeated addition sentence for each columns and rows. Okay, the first way we can say 3 rows of 4. 3 rows of 4 because we have 3 rows and inside each row we have 4 items or 4 hearts. Here 4 and here 4 and here 4. So if we want to know the total, to write the repeated addition by rows. So I have 3 rows, each row contains 4. So we can say 4 plus 4 plus 4 equals 12. Okay, and we say that this is called repeated addition because we repeat the same number. We can write the repeated addition sentence by different way if we count columns. How many columns do we have here? 4 columns. Each column contains what? Contains 3 hearts. 3 here and 3 here and 3 here and 3 here. So if I want to write the repeated addition sentence, when I count by columns, I can say 3 plus 3 plus 3 plus 3, 4 threes. Okay, 4 threes. I will add all of them. It also equals 12. So if I write the repeated addition sentence by rows, they will be the same number as we write by columns. Okay, for example, we have an array here. Let's answer these questions. The number of rows. How many rows do we have here? We said rows are the horizontal lines. Horizontal lines. 1, 2, 3. So we have 3 rows here. The number of hearts in each row. Inside each row, how many hearts do we have? 1, 2. So we have 2 hearts inside each row. Let's complete. What? Rows of what? How many rows do we have? We said we have 3 rows. Each row contains what? 2 hearts. So they are 3 rows of 2. Let's count by columns. We said columns are vertical lines. Let's count together. 1, 2. We just have 2 columns. Inside each column, how many hearts do we have? 1, 2, 3. So we have 3 hearts inside each column. The total number of hearts. Let's find the total. The total, it means the repeated addition. If we counted it by rows, we said we have 3 rows. Inside each row, we have 2. So we can say 2 plus 2 plus 2 equals 6. Another array. We have another array here. Let's solve the questions. The number of columns, columns are vertical lines. How many vertical lines here? 1, 2, 3. We have 3. The number of stars in each column. The number of stars in each column. How many stars in each column? Just 2 stars. 2 stars in the first column, 2 stars in the second, and 2 stars in the third. How many rows do we have? How many rows? Rows, horizontal lines. How many rows? 2 rows. Inside each row, how many stars? 3 stars. So we have 2 rows of 3 stars. How many columns do we have? Columns, vertical lines. Columns, vertical lines. How many vertical lines here? 1, 2, 3. Inside each column, how many hearts? 2 hearts. Let's write the total number of stars. Okay, we have 3 columns. Inside each column, we have 2. So we can say 2 plus 2 plus 2 equals 6 also. Let's help our rabbit to reach the carrot. Here we will use skip counting to reach the carrot. Skip counting help us to solve repeated addition easily. We said repeated addition, it means we add the same number many times. This is the same idea of skip counting. Here we have a rabbit. He wants to reach his carrot by skip counting by 2. Okay? Skip counting by 2, it means I will add 2 each time. So 0 plus 2 equals 2. Then I will add 2, it will be 4. Then I will add 2, it will be 6, and so on. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Here our rabbit reached his carrot. Another rabbit here wants to reach his carrot by skip counting by 3. So each time I will add 3. 3 plus 0 equals 3. Then we will add 3, it will be 6. Then we will add 3, it will be 9, and so on. Okay, so I'll tell you a song. Please Listen to me and repeat it many times. 3, 6, 9, 12, 15, 18, and 21. Count by 3, every one. 24 and 27. 30 is the last one. Okay, and you can skip counting by 3 many times, so it will be 33, 36, and so on. Okay, let's repeat our song. 3, 6, 9, 12, 15, 18, and 21. Count by 3, every one. 24 and 27. 30 is the last one. Yeah, great, Bunny, you reached your carrot. Here our bunny wants to reach his carrot using skip counting by 4. So each time we will add 4. 0 plus 4, 4. 4 plus 4, 8, and so on. Okay, I'll tell you a song to help you to memorize it. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Another time. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Yeah, great, Bunny, you reached your carrot. Another bunny here wants to reach his carrot using skip counting by 5. So each time I will add 5. So 0 plus 5, 5. 5 plus 5, we used it in doubles, or we studied it in doubles in grade 2. 5 plus 5, 10. 10 plus 5, 15, and so on. Also, we have here a song to memorize us for skip counting by 5. Okay, 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Again, 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Great, Bunny, you reached your carrot. Lesson 15, the apply part. Here we have the grocery store picture. It's like our grocery store, okay? Here we have some fruits and vegetables, and they are arranged in arrays and groups. You can find here that apples arranged in an array, but banana, do we have array here in banana? No, they are groups, okay? For example, if we looked at banana, we will find it contains from rows and columns. How many rows do we have for apples? How many rows? Remember, rows are horizontal lines. Horizontal lines. So, how many rows? 1, 2, 3, 4. We have 4 rows of apples. Inside each row, we have 3 apples. So, if we want to find the total, we can say we have 4 rows and each row contains 3 apples. We can say 3 plus 3 plus 3 plus 3. 4 threes, okay? We will add them. We can add them. 3 plus 3 plus 3 plus 3. 3 plus 3, 6. Plus 3, 9. Plus 3, 12. So, all of them are 12 apples. We can also find the total by a different way. Do you remember skip counting? We said in skip counting we add each time the same number. Here we are adding 3, so we can add each time a 3. Okay, we will add each time 3 4 times. Let's sing the song together.
3, 6, 9, 12. Stop. They are 4 threes. We stopped at number 12. 3, 6, 9, 12. Okay, let's move to banana. Here, how many bananas do we have? To find the total, we will find them in array or group. Group, they are not array. They are not rows and columns. Okay, so we have 3 groups of banana. Inside each group we have 3 bananas. Okay, so 3 repeated 3 times. So we can say 3 plus 3 plus 3 equals 9. Or we can skip counting by 3 times. 3, 6, 9. Okay, carrots. Let's move to carrots. Here, carrots are in group or array? Group. Okay, group. And here, carrots have 5 groups. 5 groups. Inside each group we have 3 carrots. So we repeat 3 5 times. We can add 3 5 times. 3 plus 3 plus 3 plus 3 plus 3 equals 15. Or we can skip counting by 3 5 times. Let's sing the song together. 3, 6, 9, 12, 15. Yes, they are 15. Mango. How many mangoes do we have here? They are in array or in group? Array. We have rows and columns. How many rows do we have? 1, 2, 3, 4. We have 4 rows. Inside each row, how many mangoes inside each row? 1, 2, 3, 4, 5. So we have 5 repeated 4 times. We can say 5 plus 5 plus 5 plus 5 equals 20. Or we can skip counting by 5 4 times. Let's count together. 5, 10, 15, 20. Yes, they are 20. Cans. How many cans do we have? Cans here on the shelf. Okay, they are in blue color. Cans. Here cans are arranged in an array. And how many rows do we have? 3 rows. Inside each row, 1, 2, 3, 4, 5, 6, 7. 7 cans. So I have 7 plus 7 plus 7 equals 21. Okay. Cucumber. Cucumber here in the bottom of our picture. They are arranged in an array. We have 2 rows. Inside each row, 1, 2, 3, 4, 5. 5 cucumbers. So we can say 5 plus 5 equals 10. Our challenge part here, he wants me to choose 3 groups to find the total. I will choose bananas, carrots, and mangoes. Okay, we will add all of them to find the total. Do you remember the total? It's a keyword for addition. Sum and all together, total. Do you remember this? So total is a keyword for addition. To find the total, I will add bananas plus carrots plus mangoes. Bananas, I have here 9 bananas and 15 carrots and 20 mangoes. Okay, so the total 15 plus 20, 35, 35 plus 9, 44. Or you can add it using tens and ones. Do you remember? Tens and ones, and add ones together and tens together. Number 2, in the challenge part, pick 5 groups and order the totals from the groups from the smallest to the greatest. So we will arrange the total here from the smallest to the greatest. What is the smallest total here? 9, then 10, then 15, then 20, then 21. Here I choose to arrange bananas, carrots, mangoes, and cans and cucumbers. I didn't choose apples, okay? Lesson 16, the apply part. Look at each star array and record the number of rows and the number of stars in each row. Then find the total of stars. Array number 1. In array number 1, how many rows do we have? Number of rows. We said rows are the items arranged in horizontal lines like this. Let's count rows together. 1, 2, 3, 4. So the number of rows, 4. The number of stars in each row. In each row. How many stars in each row? In the first row, how many stars? 4. In second, 4, and so on. So the number of stars in each row, 4. The total number of stars. I want to find the total now, so I will use repeated addition or skip counting. We said we have 4 rows. Inside each row or in each row we have 4. So I will add 4 plus 4 plus 4 plus 4 or skip counting by 4. Do you remember the song? 4, 8, 12, 16. Stop. We repeated 4 times. So they are 16. Number 2, the array number 2, number of rows. Again, let's find the number of rows. Horizontal lines. Count with me. 1, 2, 3, 4. So number of rows, 4. The number of stars in each row. In each row, how many stars in each row? 3 stars. To find the total number, we have here 4 rows, in each row 3. So we can say 3 plus 3 plus 3 plus 3 equals 12. From our skip counting, 3, 6, 9, 12. Okay? Or I can find it by different way. I can find the total from columns. Do you remember columns? Columns, L, columns. L in columns refers to vertical lines like this. Let's count columns together. 1, 2, 3. I have 3 columns. Inside each column, 1, 2, 3, 4. I have 4. So I can say 4 plus 4 plus 4 also equals 12. From the song of skip counting by 4, 4, 8, 12. So the total number 12. I can find it using columns or rows. It's up to you. You can use anything, okay? Number 3 here. How many rows do we have? Rows, horizontal, rows. 1, 2, 3, 4. Number of stars in each row. Number of stars in each row. 1, 2, 3, 4, 5. Okay, the total number of stars. Now I want to find the total. I have 4 rows, in each row 5. So I can repeat 5 4 times. 5 plus 5 plus 5 plus 5 equals 20. The last array, I have here how many columns? How many rows? 1, 2, 3, 4, 5. In each row, how many stars? In each row, 2. So to find the total, I can add 2 5 times. 2 plus 2 plus 2 plus 2 plus 2. Or I can say 2 columns, and inside each column I have 5. So I can say 5 plus 5. Or 2 plus 2 plus 2 plus 2 plus 2. The total 10. Here in this page, it's like the previous one, you can complete it by yourself. Okay. The challenge part. Choose an array from the apply activity if each star costs 2 LE. How much would it cost to buy the whole array? Okay, here's our array. This is our array, okay? In this array, each one star costs 2 LE. Its price 2 LE. To find the total cost, we want to know the total number of stars. The total number of stars here, I can say they are 2 columns, and in each column I have 5. So 5 plus 5 equals 10 stars. So all of these stars are 10 stars, and each one star costs 2. So the first one 2 plus the second 2 plus the third 2 plus fourth 2 and so on. So to find the total, I will add 2 10 times. Okay, so 2 plus 2 plus 2 plus 2 10 times. The total will be 20 LE. Don't forget LE, because we are writing here the cost of the whole array. Let's move to the next page, the math journal. Look at the star array below. Some of stars have been ripped off. How many stars were in the original array? Here it's like our paper. When we rip our paper, cut it, okay? This was a whole array, and we ripped it, we cut it, okay? I wanted to know how many stars here I cut. The stars in original array before I cut it, okay? Here, this array contains some rows and some columns before I cut it, okay? And inside each row, or in each row, how many stars in each row? 1, 2, 3, 4, 5. So to be an array, we shouldn't have any gaps. So all rows must have 5 stars. So in the third row, we will add 2 stars to make 5. Okay? And in the fourth row, we will add 3 stars to make 5 also. Multiplication. Multiplication means repeated addition. It's a different way to know the total, like repeated addition. It's different strategy from repeated addition, okay? If I have here 3 groups of apples, the total apples here, how many groups? 3 groups. In each group, how many apples? 4 apples. So I have here 4, 4, 4. To find the total using repeated addition, I add 4 plus 4 plus 4 equals 12, or by skip counting, 4, 8, 12. Okay, now we will use multiplication. Multiplication means here I have 4 and I repeated it. How many times I repeated it? I repeated 4 how many times? 3 times. So 4 is repeated 3 times. Okay? 4 is repeated 3 times. How can I write it using multiplication? I will write 4, then the symbol of multiplication. Do you know the symbol of addition? It's a plus, okay? But the symbol of multiplication is called times. So we will say 4 times. How many times I repeated 4? 3. Okay, so 4 times 3. 4 times 3. Again, here I have 3 groups of apples. In each group I have 4. By repeated addition I can say 4 plus 4 plus 4. But in multiplication I know that I repeated 4 3 times. So I will write the number I repeat. What is the number I repeat? 4. How many times I repeat 4? How many times I repeat 4 here? 3. So I will write 4 times this symbol, which is like X, is called times. 4 times 3 equals 12. It's the same result. Okay? We will memorize the tables of multiplication. It's like skip counting. Here I repeated 4 3 times. I can say 4, 8, 12. When I repeat 4 3 times, I got 12. Okay? These numbers which I multiplied together, here I multiplied 4 by 3. I multiplied 4 by 3. This is why we call it multiplication. Okay, we call it multiplication. So I multiplied 4 by 3. And when we want to read it, we say 4 times, don't say by. 4 times 3 equals 12. These numbers that I multiply together are called factors, and the result here is called product, Do you remember in addition, we called the numbers we added together addends, and the result is called sum, Here in multiplication, we call them factor, and the result is called product. Okay, so say with me, factor, product, factor, product. Commutative property. We used the commutative property in addition before, and we said commutative property in addition means we can switch addends and the sum will not change. When I have 1 plus 2 equal 3, I can switch addends and say 2 plus 1 equal 3. 1 plus 2 equals 2 plus 1. Okay? All of them equal 3. Here in multiplication, I have commutative property also. But I can say we can switch factors and the product will not change. We can switch factors and the product will not change. We said the numbers we repeated together, we multiplied together, their name is factors. Okay? And the result is called product. So we can switch factors and the product will not change. For example, I have here 2 arrays. The first array, how many rows in the first array? How many rows? 3 rows. In each row, how many hearts? 2 hearts. So I can say 3 times 2 equals 6. 3 times 2 equals 6. And remember with me, when we give any array a name, we can say 3 by 2. But here in multiplication, to find the total, I can say 3 times 2. Okay? 3 times 2 equals 6. The next array, I have 2 rows. 2 rows. In each row, 3 hearts. So, I can say 2 times 3 equals 6 also. So, when I switch the factors, the product remains as it is. The product remains as it is. So, 3 times 2, it's the same. 2 times 3, all of them equal. For example, here I have 3 groups. I have 3 groups. Inside each group, I have 3 triangles. So I have 3 groups of 3 triangles. If I want to find them using multiplication to find the total, I can say 3 times, how many times I repeat 3? 3. So 3 times 3 equals 9. Another groups here, I have 2 groups. In each group, I have 4 stars. So I can say 2 groups of 4. 2 groups of 4. To write them in multiplication, I can say 2 times 4 equals 8. Okay, I get this 8 from, I can skip counting by 2 4 times. 2, 4, 6, 8. Or I can say skip counting by 4 2 times. 4, 8. Here in lesson 17, the math journal, we have 2 images and I want to answer these questions. How are these images similar? How are these different? And find the total. Now I can say in the first image I have an array of eggs. To find the total, I can ask myself how many rows do I have, and inside each row how many eggs. So I can say the total eggs in this array, 5 rows, and in each row I have 6 eggs, equals 30. The total equals 30. Okay? Here, the next image, I have here circles and dots. Circles and dots. I have some groups. Okay, 6 groups. In each group I have 5 dots. So I can say 6 times 5. 6 times 5 equals 30 also. We can use it from skip counting by 5 6 times. Do you remember the song? 5, 10, 15, 20, 25, 30. Okay, so they are 30. Here we can find the result is similar in both images. They are the same total. So I can say 5 times 6 equals 6 times 5, and this is called commutative property. Now let's apply on lesson 18. Let's apply on repeated addition and multiplication by a game. Here I'll give you some groups and I want you to find the repeated addition and multiplication, and we will compare your product and your partner's product, okay, your friend's product. Here in the first solved example, here we have 3 groups and the repeated addition will be 3 plus 3 plus 3, because each group contains 3. So we have 3 groups. Each group contains 3. So it will be 3 plus 3 plus 3 equals 9. If we use the multiplication, we will ask ourselves, what is the number we repeat? 3. How many times we repeat 3? 3 times. So 3 times 3 equals 9. And here our product 9 and our partner's product 15. So our partner's product is bigger. In round 1, I gave you these 3 groups. Each group contains 5 dots. 5 dots. Let's find the repeated addition equation. How many groups do we have? 3. Each group contains 5. So we can, to find the total by repeated addition, we can add 5 plus 5 plus 5 equals 15, or by skip counting 5, 10, 15. Okay? By multiplication, I will ask myself, what is the number I repeat here? In repeated addition, what is the number I repeat? 5. How many times I repeat 5? How many times? 1, 2, 3. So I repeated 5 3 times. So 5 times 3 or 3 times 5 equals 15 also. Okay, so my product is 15 and my partner's product is 10. So I am bigger. In round 2, I gave you here some groups. How many groups here? 1, 2, 3, 4, 5, 6. Inside each group, I have 2 dots. So in repeated addition, I have 2 dots here, 2 dots here, 2 dots here. To find the sum or the total, I will add 2 6 times. So 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 12. Or I can find it by skip counting. I can say 2, 4, 6, 8, 10, 12. Okay? By multiplication, I will ask myself, what is the number I repeat? What is the number I repeat here? 2. How many times I repeat 2? 6 times. So it will be 2 times 6 equals 12 also. So my product 12, my partner's product 24. So he is bigger. In round 3, I gave you here some 2 groups, and inside each group I have 3 dots. 3 dots. So if I want to find the total, I will add 3 plus 3 equals 6. By multiplication, I will ask myself, what is the number I repeat? 3. How many times I repeat 3? 2. So it's 3 times 2 equals 6. My product is 6 and my partner's product 32, so he is bigger. By the same way, you can continue the rest of exercise. Here the challenge part. Draw a circle and dots board for the following equation. I have here 5 times 7. To draw groups here, I have 5 times 7. So I have 5 repeated 7 times, or 7 repeated 5 times. Okay, so I have here 7 repeated 5 times. So I draw 5 groups, and inside each group 7. So I will take number for them for number of groups and another number for the dots. So I choose 5 for groups. They are 5 groups. Inside each group I have 7. So 5 times 7, 35. Here 6 times 9, 6 times 9. 6 times 9, I can choose 6 for groups and 9 for dots. So I have 6 groups here. Inside each group I have 9 dots. Let's find the total. 6 times 9, 54. This is from timetable. In lesson 19, the apply part. Here, solve the problems below to determine whether or not there is commutative property multiplication. Here, the first array for triangles. The number of rows, how many rows do we have? We said rows are the items arranged in horizontal lines. So, we have 5 rows here. What is the number of columns? How many columns do we have? 3 columns. If I wanted to find the total, I can multiply rows times columns. Rows times columns. So, rows times columns equals 15. 5 times 3, 15. So, the total number of triangles, 15. Here, another array. How many rows do we have? Let's count the horizontal lines. 1, 2, 3. What is the number of columns? How many columns do we have? 1, 2, 3, 4, 5. 5 columns or 5 vertical lines. So I want to find the total. The total can be found by rows times columns. Rows times columns. So 3 times 5, 15. Okay, so they are the same or not? Yes, they are the same. So I have here commutative property. Okay, the next example. Here, the number of rows here. How many rows in this array of hearts? How many rows? Just 1 row. How many columns? 1, 2, 3, 4, 5, 6, 7, 8. So, the total can be rows times columns. 1 times 8 equals 1 times 8 equals 8. Okay, here in the next array, number of rows. How many rows do we have? 1, 2, 3, 4, 5, 6, 7, 8. Number of columns. How many columns? Just 1. So the total will be 8 times 1 equals 8. So they are the same. This is commutative. Let's complete lesson 19. Here we have 2 groups. Each group has 7 dots. So the number of circles, how many circles do we have? 2 circles. Inside each circle we have 7 dots. So the total number of dots, we will multiply them together, dots and circles. So 2 times 7 equals 14. The next example, we have here how many circles? 7. How many dots inside each circle? 2. So the total will be 14 because 7 times 2 equals 14. This is commutative property or not? Yes, it's commutative property. And you can complete the next by yourself. Okay, here in this grid, he wants me to draw arrays that prove commutative property of multiplication. The first array I will draw 3 rows and 5 columns. This array, this rectangle, inside it we have array. Okay, this array contains 3 rows and 1, 2, 3, 4, 5 columns. So the total can be 3 times 5 equals 15. If we wanted to find the commutative property for it, we said commutative property, it means we can switch factors and the product will not change. So we have 5 times 3 equals 15. It can be 5, we have 3 times 5, it can be 5 times 3. So let's draw 5 times 3. 5 times 3 equals 15. So I have here 5 rows and 3 columns, but in the first one I have 3 rows and 5 columns. Another example, I will draw this rectangle. Inside this rectangle we have an array. How many rows do we have and how many columns? 8 rows and 4 columns. Okay, the commutative property for it will be 8 times 4 equals 32, so 4 times 8 equals 32. Okay, we can switch factors and the product will not change, so it will be 4 times 8, 4 rows and 8 columns. The last example, we have this array 5 times 6, 5 rows and 6 columns equals 30, and the commutative property for it, 6 times 5, 6 rows and 5 columns equals 30. Here in our math journal, explain multiplication commutative property. Okay, we said commutative property means we can switch factors and the product will not change. For example, 4 times 5 equals 20, and if we switch the factors, 5 times 4 will be also 20. Here in lesson 20 we have a game. In this game I will roll the die 1 time to find the number of rows. Then we will roll the die again to find the number of columns. Then we will draw our array. I'll give you here the numbers we found on the die, and you will play this game inside your class. The first array, 2 times 4, 2 rows and 4 columns. 2 times 4 equals 8. The second array, 5 times 3, 5 rows and 3 columns. The total number will be 15. 3 times 5, it means 3 rows and 5 columns equals 15 also. 3 times 4, it means 3 rows and 4 columns equals 12. Here, 6 times 5, 6 rows and 5 columns equals 30. And the last one, 1 times 4 or 4 times 1, 4 rows and 1 column. The number of empty blocks. The empty blocks here, we can count them. To find the total number will be 16. Let's continue our game, and I will draw here some arrays. The first array, 3 times 5, 3 rows and 5 columns, so the total will be 3 times 5. Then 2 times 4, 2 rows times 4 columns, 2 times 4 equals 8. Here 6 times 2 equals 12. 6 times 2 equals 12. 6 rows and 2 columns. 4 times 2 equals 8, 4 rows and 2 columns, and so on. Then we will count the to find the number of empty blocks. The empty blocks we didn't draw on or we didn't color, they are 13 blocks. Let's move to the challenging part. Number 1. How many squares did you color in your first game board? Show how you solved this problem. To know the total number of squares we colored, we will add the product of all arrays. Here, if we have 3 times 5 equals 15, it means that the total number in this array, 15. If I want to know the total number of all arrays, I will add the products in the first game. So 8 plus 15 plus 12 plus 4 plus 15 plus 30 equals 84. Number 2, can you answer the question above in another way? Can you find the total of all arrays without adding? Sure, by counting. Okay. Number 3, which counting strategy from question 1 or 2 was more efficient? Which one strategy do you prefer? Do you prefer adding the total arrays or product of all arrays, or counting? I think adding is more efficient because it saves time. Thank you for listening and hope you enjoyed.